Suara panggilan bersujud.
Hei Bianda,
Mana?
iya benar mau kopi?
Titip petikan harus merah ya. Dulu petani susah, gak punya lahan, gak punya modal, gak ada yang mau menanam kopi. Kopi harganya cuma Rp2.000, gak sebanding dengan jerih payah petani.
Petani tidak tahu bagaimana lepas dari tengkulak, rentenir, dan sistem ijon. Itulah kenapa kopi akhirnya dibeli dengan harga murah.
Ceritanya dulu Bapak, kamu harus menanam kopi. Kopi bakal gini, top opi bakal ke tepi begitu.
Jadi bersama para petani kopi, kami membuat program tentang bagaimana budidaya kopi yang baik dan benar.
Semangat kebersamaan membuka jalan bagi petani untuk mengelola kawasan perhutanan sosial guna meningkatkan produktivitas dan taraf hidup mereka.
Alhamdulillah, sekarang kami bisa memelihara kebun lebih baik, modal kami berkembang, lahan yang dikelola lebih luas, anggota dari kelompok binaan kami dari belasan menjadi 200-an lebih.
Kami juga memberikan alat-alat produksi, bahkan kami membuka sekolah lapang untuk anak-anak petani.
Saya sekarang
Kami juga memberikan alat-alat produksi,
bisa begini gitu, bisa membuat lapangan pekerjaan,
Bisa buat anak sekolah dan bisa buat menabung.
dengan berbagai pendampingan yang kami lakukan, sekarang kualitas biji kopi petani lokal sudah sangat bagus. Sehingga kami berani mengambil dari mereka dan mendistribusikannya ke pasar yang lebih luas lagi.
Sekarang harga kopi bagus, petani menjadi lebih semangat. Tambah lagi klasik bean yang bisa menampung kopi kami.
Bahkan kita sudah melakukan ekspor ke beberapa negara, yaitu Amerika dan Eropa.
Kita yaitu perusahaan memang sudah walaupun petani ada buah-buah merah, proses kopi aroma wangi luar biasa nikmat ya. Kopi termasuk perjalanannya.
Manusia menyelamatkan kopi, kopi menyelamatkan hutan, hutan menyelamatkan manusia.
Saya yakin masa depan petani akan lebih cerah.
Alam memberikan penghidupan bagi kita. Kita harus terus menjaga kelestariannya. Sehingga kesejahteraan bukan hanya dirasakan untuk manusia belaka, tetapi juga untuk tanah, air, udara, binatang, tanaman, dan seluruh makhluk yang hidup di dalamnya.
Located in Yogyakarta, Indonesia, mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became the Department of Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the requirement of the society and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions. We create outstanding innovations to deal with multidisciplinary challenges in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be better. Better forever.
Bumi kita sedang terluka. Dan sudah lama ia meneriakkan sinyal-sinyal bahaya. Pemanasan global adalah ancaman nyata yang terus menghantui dan perlahan mengubah dunia kita. Banyak manusia dengan ponggahnya hidup tanpa peduli akan alam dan mengakibatkan punahnya kehidupan. Dan bumi tidak akan layak huni lagi. Tidak lagi aku, tapi kita. Bersama-sama kita memobilisasi dan menyinergikan sumber daya yang kita miliki untuk lingkungan hidup yang lebih baik. Waktu memang tidak bisa diputar kembali. Namun kita masih bisa berperan untuk melestarikan alam serta memberikan habitat yang baik, tidak hanya untuk manusia, tapi juga untuk satwa di sekeliling kita. Saatnya bersatu dan bergerak untuk bumi, untuk masa depan.
kopi dirinya mereka untuk masuk dengan harapan kehidupan lebih baik untuk kita semua.
Teduh langit senyap, mentari pun redup, mendesing suara panggilan bersujud.
Hei Benda,
Mana?
iya benar mau kopi?
Titip petikan harus merah ya.
Mohon.
Dulu petani susah, gak punya lahan, gak punya modal, gak ada yang mau menanam kopi. Kopi harganya cuma Rp2.000, gak sebanding dengan jerih payah petani.
Petani tidak tahu bagaimana lepas dari tengkulak, rentenir, dan sistem ijon. Itulah kenapa kopi akhirnya dibeli dengan harga murah.
Ceritanya dulu Bapak, kamu harus menanam kopi. Kopi bakal gini, top opi bakal ke tepi begitu.
Jadi bersama para petani kopi, kami membuat program tentang bagaimana budidaya kopi yang baik dan benar.
Semangat kebersamaan membuka jalan bagi petani untuk mengelola kawasan perhutanan sosial guna meningkatkan produktivitas dan taraf hidup mereka.
Alhamdulillah, sekarang kami bisa memelihara kebun lebih baik, modal kami berkembang, lahan yang dikelola lebih luas, anggota dari kelompok binaan kami dari belasan menjadi 200-an lebih.
Kami juga memberikan alat-alat produksi, bahkan kami membuka sekolah lapang untuk anak-anak petani kopi.
Saya sekarang kepikiran, oh saya bisa begini gitu. Bisa buat anak sekolah dan bisa buat menabung.
Dengan berbagai pendampingan yang kami lakukan, sekarang kualitas biji kopi petani lokal sudah sangat bagus. Sehingga kami berani mengambil dari mereka dan mendistribusikannya ke pasar yang lebih luas lagi.
Sekarang harga kopi bagus, petani menjadi lebih semangat. Tambah lagi klasik bean yang bisa menampung kopi kami.
Bahkan, kita sudah melakukan ekspor ke beberapa negara, yaitu Amerika dan Eropa.
Kita yaitu bersama sudah kebun petani ada buah-buah merah, proses kopi aroma wangi luar biasa nikmat ya. Kopi termasuk perjalanannya.
Manusia menyelamatkan kopi, kopi menyelamatkan hutan, hutan menyelamatkan manusia.
Saya yakin masa depan petani akan lebih cerah.
Alam memberikan penghidupan bagi kita. Kita harus terus menjaga kelestariannya, sehingga kesejahteraan bukan hanya
Located in Yogyakarta, Indonesia, mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the requirement of the society and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions. We create outstanding innovations to deal with multidisciplinary challenges in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be located in Yogyakarta, Indonesia. Mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became the Department of Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions. We create outstanding innovations to deal with multidisciplinary challenges in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be better. Better forever.
Bumi kita sedang terluka. Dan sudah lama ia meneriakkan sinyal-sinyal bahaya. Pemanasan global adalah ancaman nyata yang terus menghantui dan perlahan mengubah dunia kita. banyak manusia dengan ponggahnya hidup tanpa peduli akan alam dan mengakibatkan punahnya kehidupan. Dan bumi tidak akan layak huni lagi. Tidak lagi aku, tapi kita. Bersama-sama kita memobilisasi dan menyinergikan sumber daya yang kita miliki untuk lingkungan hidup yang lebih baik. Waktu memang tidak bisa diputar kembali. Namun kita masih bisa berperan untuk melestarikan alam serta memberikan habitat yang baik, tidak hanya untuk manusia, tapi juga untuk satwa di sekeliling kita. Saatnya bersatu dan bergerak untuk bumi, untuk masa depan.
Kopi dirinya mereka untuk masuk tentang harapan kehidupan lebih baik untuk kita semua.
Teduh langit senyap, mentari pun redup, mendesing suara panggilan bersujud.
Hei Benda,
Mana?
iya benar mau kopi?
Titip petikan harus merah ya. Dulu petani susah, gak punya lahan, gak punya modal, gak ada yang mau menanam kopi. Kopi harganya cuma Rp2.000, gak sebanding dengan jerih payah petani.
Petani tidak tahu bagaimana lepas dari tengkulak, rentenir, dan sistem ijon. Itulah kenapa kopi akhirnya dibeli dengan harga murah.
Ceritanya dulu Bapak, kamu harus menanam kopi. Kopi bakal gini, top opi bakal ke tepi begitu.
Jadi bersama para petani kopi, kami membuat program tentang bagaimana budidaya kopi yang baik dan benar.
Semangat kebersamaan membuka jalan bagi petani untuk mengelola kawasan perhutanan sosial guna meningkatkan produktivitas dan taraf hidup mereka.
Alhamdulillah, sekarang kami bisa memelihara kebun lebih baik, modal kami berkembang, lahan yang dikelola lebih luas, anggota dari kelompok binaan kami dari belasan menjadi 200-an lebih.
Kami juga memberikan alat-alat produksi, bahkan kami membuka sekolah lapang untuk anak-anak petani kopi.
Saya sekarang kepikiran, oh saya bisa begini gitu, bisa membuat lapangan pekerjaan, bisa buat anak sekolah, dan bisa buat menabung.
Dengan berbagai pendampingan yang kami lakukan, sekarang kualitas biji kopi petani lokal sudah sangat bagus. Sehingga kami berani mengambil dari mereka dan mendistribusikannya ke pasar yang lebih luas lagi.
Sekarang harga kopi bagus, petani menjadi lebih semangat. Tambah lagi klasik bean yang bisa menampung kopi kami.
Bahkan, kita sudah melakukan ekspor ke beberapa negara, yaitu Amerika dan Eropa.
Kita yaitu perusahaan rumah sudah. Kebun petani ada buah-buah merah, proses kopi aroma wangi luar biasa nikmat ya. Kopi termasuk perjalanannya.
Manusia menyelamatkan kopi, kopi menyelamatkan hutan, hutan menyelamatkan manusia.
Saya yakin masa depan petani akan lebih cerah.
Alam memberikan penghidupan bagi kita. Kita harus terus menjaga kelestariannya. Sehingga kesejahteraan bukan hanya dirasakan untuk manusia belaka, tetapi juga untuk tanah, air, udara, binatang, tanaman, dan seluruh makhluk yang hidup di dalamnya.
Located in Yogyakarta, Indonesia, mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became the Department of Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the requirement of the society and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions, we create outstanding innovations to deal with multidiscipline in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be better. Better forever.
Bumi kita sedang terluka. Dan sudah lama ia meneriakkan sinyal-sinyal bahaya. Pemanasan global adalah ancaman nyata yang terus menghantui dan perlahan mengubah dunia kita. Banyak manusia dengan ponggahnya hidup tanpa peduli akan alam dan mengakibatkan punahnya kehidupan. Dan bumi tidak akan layak huni lagi. Tidak lagi aku, tapi kita. Bersama-sama kita memobilisasi dan menyinergikan sumber daya yang kita miliki untuk lingkungan hidup yang lebih baik. Waktu memang tidak bisa diputar kembali. Namun kita masih bisa berperan untuk melestarikan alam serta memberikan habitat yang baik, tidak hanya untuk manusia, tapi juga untuk satwa di sekeliling kita. Saatnya bersatu dan bergerak untuk bumi, untuk masa depan.
Kopi pirit ng mereka aku tawagin itu masuk tentang harapan kehidupan lebih baik untuk kita semua.
Teduh langit senyap, mentari pun redup, mendesing suara panggilan bersujud.
Hei Bianda,
Mana?
iya benar minum kopi?
Titip petikan harus merah ya.
Mohon.
Dulu petani susah, gak punya lahan, gak punya modal, gak ada yang mau menanam kopi. Kopi harganya cuma Rp2.000, gak sebanding dengan jerih payah petani.
Petani tidak tahu bagaimana lepas dari tengkulak, rentenir, dan sistem hijau. Itulah kenapa kopi akhirnya dibeli dengan harga murah.
Ceritanya dulu Bapak, kamu harus menanam kopi. Kopi bakal gini, top opi bakal ke tepi begitu.
Jadi bersama para petani kopi, kami membuat program tentang bagaimana budidaya kopi yang baik dan benar.
Semangat kebersamaan membuka jalan bagi petani untuk mengelola kawasan perhutanan sosial guna meningkatkan produktivitas dan taraf hidup mereka.
Alhamdulillah, sekarang kami bisa memelihara kebun lebih baik, modal kami berkembang, lahan yang dikelola lebih luas, anggota dari kelompok binaan kami dari belasan menjadi 200-an lebih.
Kami juga memberikan alat-alat produksi, bahkan kami membuka sekolah lapang untuk anak-anak petani kopi.
Saya sekarang kepikiran, oh saya bisa begini gitu, bisa membuat lapangan pekerjaan, bisa buat anak sekolah, dan bisa buat menabung.
Dengan berbagai pendampingan yang kami lakukan, sekarang kualitas biji kopi petani lokal sudah sangat bagus. Sehingga kami berani mengambil dari mereka dan mendistribusikannya ke pasar yang lebih luas lagi.
Sekarang harga kopi bagus, petani menjadi lebih semangat, tambah lagi klasik bean yang bisa menampung kopi kami.
Bahkan, kita sudah melakukan ekspor ke beberapa negara, yaitu Amerika dan Eropa.
Kita yaitu perusahaan rumah sudah kebun petani ada buah-buah merah, proses kopi aroma wangi luar biasa nikmat ya. Kopi termasuk perjalanannya.
Manusia menyelamatkan kopi, kopi menyelamatkan hutan, hutan menyelamatkan manusia.
Saya yakin masa depan petani akan lebih cerah.
Alam memberikan penghidupan bagi kita. Kita harus terus menjaga kelestariannya. Sehingga kesejahteraan bukan hanya dirasakan untuk manusia belaka, tetapi juga untuk tanah, air, udara, binatang, tanaman, dan seluruh makhluk yang hidup di dalamnya.
Located in Yogyakarta, Indonesia, mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became the Department of Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the requirement of the society and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions. We create outstanding innovations to deal with multidisciplinary challenges in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be better. Better forever.
Bumi kita sedang terluka. Dan sudah lama ia meneriakkan sinyal-sinyal bahaya. Pemanasan global adalah ancaman nyata yang terus menghantui dan perlahan mengubah dunia kita. Banyak manusia dengan pongahnya hidup tanpa peduli akan alam dan mengakibatkan punahnya kehidupan. Dan bumi tidak akan layak huni lagi. Tidak lagi aku, tapi kita. Bersama-sama kita memobilisasi dan menyinergikan sumber daya yang kita miliki untuk lingkungan hidup yang lebih baik. Waktu memang tidak bisa diputar kembali. Namun kita masih bisa berperan untuk melestarikan alam serta memberikan habitat yang baik, tidak hanya untuk manusia, tapi juga untuk satwa di sekeliling kita. Saatnya bersatu dan bergerak untuk bumi, untuk masa depan.
Kopi dirinya mereka aku tangan itu masuk tentang harapan kehidupan lebih baik untuk kita semua.
Teduh langit senyap, mentari pun redup, mendesing suara panggilan bersujud.
Hei Bianda,
Mana?
iya benar mau kopi?
Titip petikan harus merah ya. Dulu petani susah, gak punya lahan, gak punya modal, gak ada yang mau menanam kopi. Kopi harganya cuma Rp2.000, gak sebanding dengan jerih payah petani.
Petani tidak tahu bagaimana lepas dari tengkulak, rentenir, dan sistem hijau. Itulah kenapa kopi akhirnya dibeli dengan harga murah.
Ceritanya dulu Bapak, kamu harus menanam kopi. Kopi bakal gini, top opi bakal ke tepi begitu.
Jadi bersama para petani kopi, kami membuat program tentang bagaimana budidaya kopi yang baik dan benar.
Semangat kebersamaan membuka jalan bagi petani untuk mengelola kawasan perhutanan sosial guna meningkatkan produktivitas dan taraf hidup mereka.
Alhamdulillah, sekarang kami bisa memelihara kebun lebih baik, modal kami berkembang, lahan yang dikelola lebih luas, anggota dari kelompok binaan kami dari belasan menjadi 200-an lebih.
Kami juga memberikan alat-alat produksi, bahkan kami membuka sekolah lapang untuk anak-anak petani kopi.
Saya sekarang kepikiran, oh saya bisa begini gitu, bisa membuat lapangan pekerjaan, bisa buat anak sekolah, dan bisa buat menabung.
Dengan berbagai pendampingan yang kami lakukan, sekarang kualitas biji kopi petani lokal sudah sangat bagus. Sehingga kami berani mengambil dari mereka dan mendistribusikannya ke pasar yang lebih luas lagi.
Sekarang harga kopi bagus, petani menjadi lebih semangat, tambah lagi klasik bean yang bisa menampung kopi kami.
Bahkan, kita sudah melakukan ekspor ke beberapa negara, yaitu Amerika dan Eropa.
Kita yaitu bersama sudah kebun petani ada buah-buah merah, proses kopi aroma wangi luar biasa nikmat ya. Kopi termasuk perjalanannya.
Manusia menyelamatkan kopi, kopi menyelamatkan hutan, hutan menyelamatkan manusia.
Saya yakin masa depan petani akan lebih cerah.
Alam memberikan penghidupan bagi kita. Kita harus terus menjaga kelestariannya, sehingga kesejahteraan bukan hanya dirasakan untuk manusia belaka, tetapi juga untuk tanah, air, udara, binatang, tanaman, dan seluruh makhluk yang hidup di dalamnya.
Located in Yogyakarta, Indonesia, mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became the Department of Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the requirement of the society and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions, we create outstanding innovations to deal with multidisciplinary challenges in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be better. Better forever.
Bumi kita sedang terluka. Dan sudah lama ia meneriakkan sinyal-sinyal bahaya. Pemanasan global adalah ancaman nyata yang terus menghantui dan perlahan mengubah dunia kita. Banyak manusia dengan ponggahnya hidup tanpa peduli akan alam dan mengakibatkan punahnya kehidupan. Dan bumi tidak akan layak huni lagi. Tidak lagi aku, tapi kita. Bersama-sama kita memobilisasi dan menyinergikan sumber daya yang kita miliki untuk lingkungan hidup yang lebih baik. Waktu memang tidak bisa diputar kembali. Namun kita masih bisa berperan untuk melestarikan alam, serta memberikan habitat yang baik, tidak hanya untuk manusia, tapi juga untuk satwa di sekeliling kita. Saatnya bersatu dan bergerak untuk bumi, untuk masa depan.
Kopi diri mereka aku telah masuk tentang harapan kehidupan lebih baik untuk kita semua.
Teduh langit senyap, mentari pun redup, mendesing suara panggilan bersujud.
Hei Benda,
Mana?
iya benar mau kopi?
Titip petikan mak harus merah ya. Dulu petani susah, gak punya lahan, gak punya modal, gak ada yang mau menanam kopi. Kopi harganya cuma Rp2.000, gak sebanding dengan jerih payah petani.
Petani tidak tahu bagaimana lepas dari tengkulak, rentenir, dan sistem hijau. Itulah kenapa kopi akhirnya dibeli dengan harga murah.
Ceritanya dulu Bapak, kamu harus menanam kopi. Kopi bakal gini, top opi bakal ke tepi begitu.
Jadi bersama para petani kopi, kami membuat program tentang bagaimana budidaya kopi yang baik dan benar.
Semangat kebersamaan membuka jalan bagi petani untuk mengelola kawasan perhutanan sosial guna meningkatkan produktivitas dan taraf hidup mereka.
Alhamdulillah, sekarang kami bisa memelihara kebun lebih baik, modal kami berkembang, lahan yang dikelola lebih luas, anggota dari kelompok binaan kami dari belasan menjadi 200-an lebih.
Kami juga memberikan alat-alat produksi, bahkan kami membuka sekolah lapang untuk anak-anak petani kopi.
Saya sekarang kepikiran, oh saya bisa begini gitu. Bisa membuat lapangan pekerjaan, bisa buat anak sekolah, dan bisa buat menabung.
Dengan berbagai pendampingan yang kami lakukan, sekarang kualitas biji kopi petani lokal sudah sangat bagus. Sehingga kami berani mengambil dari mereka dan mendistribusikannya ke pasar yang lebih luas lagi.
Sekarang harga kopi bagus, petani menjadi lebih semangat. Tambah lagi klasik bean yang bisa menampung kopi kami.
Bahkan, kita sudah melakukan ekspor ke beberapa negara, yaitu Amerika dan Eropa.
Kita yaitu bersama sudah. Walaupun petani ada buah-buah merah, proses kopi aroma wangi luar biasa nikmat ya. Kopi termasuk perjalanannya.
Manusia menyelamatkan kopi, kopi menyelamatkan hutan, hutan menyelamatkan manusia.
Saya yakin masa depan petani akan lebih cerah.
Alam memberikan penghidupan bagi kita. Kita harus terus menjaga kelestariannya. Sehingga kesejahteraan bukan hanya dirasakan untuk manusia belaka, tetapi juga untuk tanah, air, udara, binatang, tanaman, dan seluruh makhluk yang hidup di dalamnya.
Located in Yogyakarta, Indonesia, mechanical engineering was established in 1959 as one of the oldest departments in Faculty of Engineering, Universitas Gadjah Mada. To meet the high demand for industrial competencies, the Industrial Engineering Study Program was founded in 1998, so the name became the Department of Mechanical and Industrial Engineering. In Mechanical and Industrial Engineering, we are committed to constantly developing into a world-class department in academics and research. We carry out education, research, and community service to meet the requirement of the society and the engineering world. Our excellences in academics have been reflected through national and international accreditation. We provide the best environment and support for all the department members. Various sophisticated research has been consistently delivered through excellent support of technology. Over collaboration and synergy with the governments, industries, and other higher education institutions. We create outstanding innovations to deal with multidisciplinary challenges in society. To handle obstacles in society and improve their welfare are our focus. So we observe, empathize, and engineer solutions. We design, disrupt, and reimagine the impossible. Engage in lifelong learning to adapt to new challenges. We translate problems into opportunities. We work for and closely with the people. We seek, solve, and share. We optimize everything to be better. Better forever.
Good morning, ladies and gentlemen, and welcome to the 12th International Conference on Thermofluid 2021. The 12th International Conference on Thermofluid's objectives are bringing together researchers, scientists, academics, policymakers, and professionals to exchange information and identify research needs in the areas of thermofluids engineering. In this annual conference, we seek to expand the scope to a wider community of researchers, allowing a higher quality of knowledge transfers and communication. We hope that by collaborating with researchers, scientists, academics, policymakers, and professionals from different countries, there will be an increase in both the quality and visibility of publication. Distinguished participants, we are glad to inform you that at this particular conference, we are collaborating with the Indonesian government via Indonesian Continuous Development, via Indonesian Environmental Fund, or BPDLH, and we're looking forward to the continuous development of the research and technology in thermofluids engineering for the current and future energy and environment sustainability. Hopefully, all of the enthusiastic participants that we have here today will find our lineup to be engaging and insightful in the thermofluids line of study. For today's agenda, there will be 4 presentations from 4 different keynote speakers. The first keynote speaker is Professor Kiyoshi Saito from Waseda University, followed by Mr. Krisnawan Andite as the Director of EBTKE, then Professor Michael Beckman from Technische Universiteit Dresden, and lastly, Professor Denar Diananto from Gajah Mada University. And also, there will be papers from various themes. Before we start this conference, we would like to invite all participants, speakers, and staff to stand up straight for the singing of the Indonesian national anthem, Indonesia Raya. You may now be seated. Next, we would have a welcoming speech from Mr. Hifni as the chair of the organizing committee of the 12th International Conference on Thermofluid 2021. Mr. Hifni, the time is yours. Please wait for Mr. Hifni to get ready first.
Good morning, ladies, gentlemen, dear colleagues. On behalf of the conference committee, it's my pleasure to welcome all of the great scientists, academicians, researchers, delegates, and students from all over the world to attend the 12th International Conference on Thermofluid 2021 from November 10th to 11th, 2021. This is the 12th series of annual Thermofluid Conference held by the Department of Mechanical and Industrial Engineering, Universitas Gadjah Mada. It's also the second series of the Thermofluid Conference held online due to the ongoing COVID-19 pandemic. But we hope it doesn't detract the value, purpose, and the quality of the event. On behalf of the committee, I would like to express our utmost gratitude to all who have made this event. We have received numerous invaluable contributions for this conference, encompassing research and development in thermal, fluid, and energy engineering. I would like to express our appreciation to our distinguished keynote speakers, Professor Kiyoshi Saito from Waseda University, Professor Michael Beckman from Technical University Dresden, Associate Professor Agus Pulung Sasmito from McGill University, Professor Alberto Coronas from Eurovirae Virgili University, Dr. Dadan Kusdiana from the Directorate General of New Renewable Energy and Energy Conservation, Ministry of Energy and Mineral Resources, Dr. Joko Hendrato from the Environmental Fund Management Agency, and Professor Dendar Lianto from Universitas Gadjah Mada. I'm also honored to mention the support from the Environmental Fund Management Agency, BPDLH, and the Department of Mechanical and Industrial Engineering and Center for Energy Studies, Universitas Gadjah Mada. Once again, I welcome you to the conference and I wish you a successful conference. Thank you.
Thank you very much, Mr. Hifni, for the welcoming speech. Now, to start this conference, let's welcome Dr. Budi Hartono as the head of the Mechanical and Industrial Engineering Department, Gadjah Mada University, to give an opening speech. Dr. Budi, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. On behalf of the Mechanical and Industrial Engineering Department, Faculty of Engineering Universitas Gadjah Mada, I would like to welcome to all our distinguished speakers, participants, and committee to the 12th International Conference on Thermofluid 2021, which is proudly hosted by our department in Universitas Gadjah Mada. Scientific studies in thermal, energy, and fluid offer great benefit not only for the scientific circle, but also for the community in general. Energy sustainability, in particular, could be considered among the most important subjects in the modern society and for the development of nations. Among many efforts, knowledge creation and dissemination are very essential to provide societal impacts. Against this backdrop, our department is fully committed to support any initiative of knowledge creation and dissemination, and in particular, this International Conference of Thermofluid. This international conference offers an excellent platform for knowledge sharing and dissemination among researchers, academia, policymakers, and professionals. This is a great venue for us where the networking opportunity is leveraged and state-of-the-arts are elaborated. As asserted by Sir Isaac Newton, if I have sinned further, it is by standing upon the shoulders of giants. In this opportunity, I would like to extend my gratitude to our distinguished speakers, Professor Michael Beckmann from TU Dresden, Germany, Professor Alberto Coronas from Universitat Rovira i Virgili, Spain, Professor Kyushi Saito from Waseda University, Japan, my old friends, Associate Professor Agus Pulung Sasmito from McGill University, Canada, and my colleague from Universitas Gadjah Mada, Indonesia, Professor Dindar Lianto. I would like to thanks to all participants for today's conference, and last but not least, the appreciation goes to the organizing committee of the conference, Dr. Hifni Aryadi and team. On behalf of our department, this Thermofluid conference is officially open. Have a great conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Budi Hartono, for the speech. As for the next session, let me introduce our moderators for today. The first session will be led by Professor Samsul Kamal, and for the second session will be led by Professor Harwin Sabtoadi. And now, into the first session of our keynote speaker presentation, Professor Samsul Kamal, the time is yours.
Jadi nunggu 9:15 according to schedule. All right, that's right. Oh, yeah, it's ready. All right. So, may I speak now? Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Okay. I think first of all, please allow me to take off my screen because I have some distance from other, so I think this will be safe to take off my. Okay, people say that after 10 years of this pandemic, then masker become, most fatal organ of people because must be covered by by. All right, that's people said like that. Okay, again, thank you very much. I think first of all, we thank God for allow us to join together in a very prestigious occasion. I think this one is usually we call it seminar on thermofluid. Yeah, I think this is very important because as we know that people, the leader of many countries already finished their talk, their discuss about especially weather as well as energy in Glasgow. And then it is very important as we know that thermofluid, that's come from thermodynamic. I think thermodynamic and fluid dynamic are the science, or I would say backbone science of the energy, as well as the climate change already talked in Glasgow. So I think it's very, very strategic occasion, very, very important, I would say, for us, I would say for words, even for words, because if we have something new or something, let's say, breakthrough on how to manage energy and how to manage thermofluid, which are as I said, is a backbone of the science of energy. Then we can quite a lot. To, let's say, efficiency, to increase the efficiency of the use of energy, as well as to protect our environmental. Okay, I think in this very occasion, this is in the schedule, is it scheduled presentation for session, first session. We very fortunate to have two very important person, very prestigious person. The first is Professor Kiyoshi Saito from Waseda University. So How are you, Professor Saito? Show up for you from Waseda? You ready, Sir Waseda? Hello? Are you there? Not yet? Okay. Beside Professor Saito, Professor Saito, we also have another very prominent person, that is Dr. Dadan Kusdiana. Right. Dadan, hello Pak Dadan, ready there? Not yet. Okay. So I think first of all, not yet. All right. I have been informed by here the Professor Pak Dadan, Dr. Dadan, he has something to do, very important to do. So it has been raised by Pak Krisnawan. Yeah, Pak Krisnawan. Okay. Yeah, I think for the time we are waiting for okay, everybody. Okay, Professor Saito, are you there? Hello, Professor Saito, are you there? Okay, can I may I introduce Professor Kiyoshi Saito? I think first of all, before he's on your screen, right? Okay, Professor Kiyoshi Saito of Waseda University, Japan. He has academic background. He's a doctor in engineering from Waseda University, and then also he has a master of engineering from Waseda University as well, and then lastly from Bachelor of Engineering Waseda University. At the moment, he is professor in Waseda. He has many activities, of course. I think people who study in energy, especially control and then thermofluid dynamic. Weather is good there?
Yes, here very good, very good. A very moderate temperature. Just like 20 degrees Celsius or something. Yes, yes.
Rainy season in Indonesia. Okay then.
Yeah.
All right, that you have a very most chance in the first chance in the keynote presentation. So please, that's the time for you.
Oh, okay. Thank you. Okay. Okay. It's okay.
Yeah.
Can you see? Okay.
Yes.
Okay. Okay. Thank you very much. I'm Kiyoshi Saito from Waseda University. This is completely first time to talk about your members, but I'm very happy I have this opportunity to introduce our chiefs. Okay, today I'd like to talk about latest air conditioning and heat pump technologies and their future. First of all, let me introduce us the university. Our university started in 1882 and located center of Tokyo, Shinjuku area. And just now the number of the students is more than 50,000, 2,000. And famous alumni from our university is Masaru Ibuka. He's the founder of Sony. And Kyunhee Lee, he's a Korean, but he's a former chairman of Samsung. And just now we have totally 5 prime ministers from our university. And Haruki Murakami, he's very famous writer. He's sometimes a Nobel Prize candidate, but not yet, but he's very, very famous writer. The typical, most famous title is Norwegian Wood, something like that. And just now we have totally 3 schools for science and engineering field. Just now we have totally 10,000 students for this field. So in 2007, the school is getting too bigger. So that's why we separated into 3 schools. One is the School of Fundamental Science and Engineering. Of course, this deals with very, very fundamental researches. And the School of Creative Science and Engineering. At the end of 2013, a solar thermal cooling system using a single double effect absorption chiller has been installed in University of Indonesia. This is interesting. This system is by solar thermal energy. When this system gets the solar thermal energy, this system can produce a cooling. Very interesting. From heat, this system can produce a cooling. We supply this cooling water to the building in the campus of University of Indonesia. This is a very new buildings, and mainly this building is used by mechanical engineering members. So we still, this system is working well in this campus. Maybe realized because this uses renewable energy. This is very with Southeast Asia. And as I've said, my main topic is heat pump systems. So I'd like to explain systems. Reduction scenario, most of you know, where COP26 was held recently, and so many discussion occurs. But in this scenario, heat pump plays very, very important role. Just now, in worldwide level, almost 30 gigatons of carbon dioxide is emitted to the outside. And, you know, until have to reduce this carbon dioxide emissions half. 40 gigatons. But if we don't do anything, it increases to 60 gigatons, double. We have to introduce so many energy-saving technologies into the society. Here, IEA, International Energy Agency, select 70 key technologies to reduce carbon dioxide emissions. There are so many good technologies: nuclear power plant, CCS, photovoltaic. So many good systems are introduced. And in this 70 key technologies, heat pump system is included. This means heat pump system is very, very important technologies. This right figure shows heat systems can do a lot to reduce carbon dioxide emissions. By 2050, almost 1 gigatons of CO2 emission reductions can be realized by heat pump technologies. Oh, very, very good contribution. 10% of carbon dioxide reduction can be realized by heat pump technologies. So that's why we have to spread technology worldwide to save the Earth. So that's why we focus on the heat pump related technologies. And just now we have so many projects. I explained a little bit of our project. This is experimental and numerical mechanism identification of some important heat pump visualization. This is two-phase flow separations for gas and liquid. When we separate two-phase flow gas and liquid, sometimes, for example, heat exchangers or evaporator, the performance of evaporator increases when we only supply the liquid. So that's why we sometimes want to separate two-phase flow gas and liquid. So what is we are investigating gas and liquid. And this is a two-phase flow heat transfer in microchannel. You know where that in the next air conditioning and heat pump systems, we cannot help using a flammable refrigerant because the current flow refrigerant has a very, very high global warming potential. But the low global potential refrigerant that is normally flammable. So that's why we have to reduce the charging quantity of refrigerant. So that's why sometimes we have to apply this kind of very, very small channels. The size of the channel is below 1 millimeter, something like that. In this case, heat transfer mechanism is completely different from the normal channels. That's why we always investigating the heat transfer performance inside the microchannels. And this is a heat and mass transfer inside the nanoscale polars. Later, I talked about the descant systems. Descant systems sometimes sometimes use materials such as silica gel or something. This kind of materials has so many small pores, and in that pores, water is absorbed and removed. So that's why heat and mass transfer mechanism inside very, very small nanoscale orders qualified. So that's why we focus on these researches. Sometimes we try to optimize heat exchangers. Sometimes we get the thermodynamic properties of refrigerant. From now, we have to change the refrigerant to green refrigerant, low GWP refrigerant. New refrigerant appears a lot, so that's why we try to get the thermodynamic properties of refrigerant. And sometimes focus on the, try to clarify film breaking mechanisms of the flow. I talked about these details later, because sometimes we use falling film type heat exchangers. In this case, how to reduce this kind of dry area, how to reduce this kind of dry area is a very, very important technology. So that's why we focus on this kind of researches. This is a heat pump analysis and optimization of whole systems. Sometimes we develop the cells to investigate behavior of heat pump systems. This is a case applied to absorption type. This is a case to solid type absorption type. As we design the system actually, and we design the system actually. Actual system we are always developing. This is a liquid type descant system that I talked about later. This is a heat pump 180 degrees, very high temperature steam we can produce. Currently 20 or something, so but we can develop this kind of systems 180 degrees heat absorb transformers. This is also a compression type heat pump systems. And sometimes we develop evaluation equipment directly because we have to get the accurate data of these systems. So that's why we directly develop the evaluation systems. And these are analysis and optimization of heat pump applied total systems. This is a multi-scale analysis that combined CFD inside the rooms and the dynamics of the air conditioning systems simultaneously. Showcase systems we try to optimize. This is a server rooms optimization with air conditioning systems. This is a vending machines the optimization of vending machine. Many vending system is installed outside the house building room, so that's why we try to optimize the vending machines. That is a lot of. Sometimes we try to optimize the total areas energy systems just like this. Okay, that is our latest releases. But from on, I'd like to introduce next generation air conditioning systems. The main topic is liquid desiccant humidity control air conditioning. Okay, as I've said, from now on, we have to reduce global warming gases emissions at least 50% by 2050. And in the air conditioning field, humidity control is very important for human health and comfort. However, conventional humidity control is inefficient and not hygienic. And this kind of air conditioning system is a very efficient alternative and is very, very hygienic. And first, I'd like to talk about conventional humidity control. We call this conventional way mechanical. Of course, mechanical dehumidification is already installed in the very, very normal air conditioning systems. In the air conditioning systems, to cool down the air, of course, warm and humid air is coming to this unit. This is cyclometric chart, and this warm and humid air is first cooled down from number 1 to number 2. And here, if we cool down this warm and humid air, deep cooling, normally temperature is about 0 degrees Celsius inside the refrigerant. In this case, we can get a lot of condensate and we can remove the moisture from the air. Just like number 2. But this temperature is too low, so sometimes we have to reheat this air, and we can finally get the very, very moderate temperature air, just like here, number 3. But in this system, we use a lot of energies, and reheat sometimes use more and more energy, input energy. And condensate leads to mold formation. Sometimes when you just start the automotives, you smell a lot. This is coming from the mold. Microbial growth occurs. So that's why this mechanical dehumidification is not so good for carbon neutral viewpoint, but also for our human health. And this is a desiccant humidity controls. Humidity controls consist of a dehumidification process and cooling process. Of course, fast warming and this dehumidification normally is just like this. This is a piles of corrugated sheet, just like this. And dehumidification solution is flowing on this sheet, each sheet. And between these sheets, moist air is going through, and direct contact between dehumidification materials, fluid, direct of these fluid, and moist air is dehumidified, and we can get dry air. So this is a cyclometric chart. Here first, warm and humid air is coming, and in this dehumidification process, air is dehumidified, but temperature increases because this process is heat release process. That's why we have to cool that with cooling process. But the important point is in the conventional mechanical dehumidification, the temperature too much, 0 degrees Celsius, something like that. But in this process, we have to only cool down just like temperature is just like 15 degrees Celsius or something. So the system performance increases greatly, and no reheating station, so we can improve the energy efficiency greatly, and hygienic, better indoor quality we can get. So this is a configuration of liquid desiccant dehumidification systems. This system consists of dehumidifier and regenerator, mainly consists of two parts. And in dehumidifier process air and strong LI solutions, this is a desiccant, directly contact with each other or on the media, this packed bed, as I've talked. And process air, humid air is dehumidified by LICL solutions, desiccant, liquid desiccant. And in this process, as I've said, solution should be cooled down because heat is released. And then when this liquid desiccant absorbs a lot of water, it cannot absorb water anymore. So that's why we have to regenerate that. So we move the liquid desiccant to regenerator with some pumps. And in the regenerator, regeneration air and weak solution are directly contact with each other on this media packed bed. And solution is enriched by regeneration air. LICL solution should be heated because water is easily removed from a hot solution. It's okay. So that's why we have to heat up this regeneration process. And this is a driving source of this total systems. But important point, we need only 6 degrees Celsius heat to drive these systems. This means we can sometimes use the waste heat or solar thermal energies. So if we drive this system with this kind of waste heat or renewable energies, the performance of this system is very high. So there is other way to drive these systems. This system called hybrid dehumidification systems. As I've said, in the dehumidification process, heat release process, that's why we have to cool down. And regeneration process, we have to heat up. So that's why. So you can easily imagine if we apply heat pump systems can cool down some evaporator. And in the condenser, heat pump system release some heat, so we can use this heat. So this combination is very, very good, and performance of this system is extremely high. So that's why this system is very good to get the dry air and to get the cooled air. Very good systems. But there is a problems of desiccant humidity control systems. Currently, we use liquid desiccant such as LIBL, LICL, and CCL. They are very, very corrosive to most of the materials. Because of this, this packed bed gas liquid contactor, that is a pile of corrugated sheet. This is made by just cellulose because we can't use metals. And also for heat exchangers, we cannot help using titanium heat exchangers. Quite high prices. We have just now in the current situation, we cannot help using a corrosive desiccant fluids. That's why we use very, very expensive materials, metals. That's why this system is very expensive, and we cannot help use 2 parts of process. System becomes very large. This is a big problems of desiccant humidity control systems. But recently, we developed a completely new liquid desiccant, ionic liquid, with some Germany chemical companies. This liquid is not corrosive and has excellent solubility and has high thermal and chemical stability and has low volatility and it's no flammable. That's why very good liquid desiccant we developed. So that's why we can use aluminum. So that's why we can make so many kind of systems. This system is combination system of packed bed and heat exchangers. So I'd like to explain the flow mechanisms. This heat exchanger consists of tubes. Inside tube, refrigerant or cooling water is going through, and outside there is a fin plate type fins located. This is a kind of plate fin and tube heat exchangers. And from top of here, we supply the discount solutions on this plate fins. And air is goes between these fins, and direct contact of these moist air and liquid desiccant. Moist air is dehumidified. And this process is heat release process. Refrigerant or cooling water cool down this process. So that's why this heat exchanger use a three fluid: moist air, liquid desiccant, and cooling materials. And this heat exchanger is combined heat exchanger of corrugated factory bed and heat exchangers. That's why this system is very small, and we can make the total system compact, more and more compact. Problems. Because this ionic liquid is, have a very, very high viscosity. So that's why when we try to supply this liquid desiccant systems on the fin plate, normally this kind of very, very simple, very thin, very good falling film is produced on the outside when we just use water or something. But this ionic liquid have a so very, very high viscosity. Sometimes this kind of dry area occurs just like this. Only liquid desiccant makes this kind of rivulet. So many dry patches, so many dry areas occur. So that's why heat and mass transfer performance decreases greatly. So that's why we have to design this kind of three fluid heat exchangers. We have to predict the heat and mass transfer in detail. Model based on the principle of minimum energy. What is the principle minimum energy? At the same flow rate, the liquid configuration that will occur is the one with the minimum energy. So using this thermodynamic principle, it is possible to establish the wettability model of the flow configurations. So this film flow have energy, and the flow energy is a combination of kinetic energy and surface tension energy. So as I've said, when this falling film flows stably, the energy becomes minimum. So the principle of minimum energy gives the how falling film is formulated, just like this. And finally, we can make following formulations of wettability just like this. So we use this formulation. We can predict the wettability of falling film. Okay. In the very, very unique, interesting point is when we decrease the desiccant flow rate, wettability becomes just like this. This black area is a well-wetted area, and this white area is a dry patch area. When we decrease the solution flow rate, the flow pattern changes just like this. But when we increase the desiccant flow rate, wettability performance is just like this. Interesting point is the top of the figure and just below this figure is the same flow rate, but the wettability pattern is completely different. This is caused by contact angles. Sometimes we call this phenomenon hysteresis behavior. So this is caused by a contact angle just like this. advancing contact angle and receding contact angle is different. That's why this kind of phenomenon occurs. This is a simulation and experimental result, solution flow rate and wettability. When we increase the solution flow rate, just like red line, just like red plot, just like here, gradually increase the wettability. But when we decrease the solution flow rate, good wettability is kept, but suddenly wettability decreases. And the plot is experimental result and lines simulation result, calculation result, but both of them agree with each other very well. That's why we find out this kind of histless behavior, but also we validate our simulation model, calculation models. So we apply this formulation to the design of total heat exchangers. So in this heat exchangers, so many complex phenomena occurs, mass transfers between air and solutions. Heat transfer also occurs, and heat transfer occurs between liquid test current and cooling media. That's why a mathematical model becomes very, very complex. Mass conservation, gas liquid cooling, energy equation, gas liquid cooling water, heat and mass transfer equations, gas liquid cooling waters, and momentum equations, and heat and mass transfer coefficient for gas side, liquid side, cooling water side. So totally, very, very mathematical model becomes complex, but we have already developed this kind of simulators to calculate the performance of heat exchangers total systems. Very easy to use this simulators. These are the very, very strong GUIs on the Excel. So I'd like to introduce our simulators briefly. Very, very easy to handle. This is just an Excel. And we select some modules that express each devices, heat exchangers, pumps, valves, something like that. And all we have to do is select module and connect each modules. And put some input parameters here, save, and just put the calculation buttons, start calculations, and we can get the data. And the data is data are shown on the Excel sheet. So we can easily use output data. Sometimes we can easily make figures or something. Very easy to handle. We have already developed this simulators that is called energy flow plus M. That's why we can easily calculate very, very difficult mathematical models. Using mathematical models, we can calculate the performance of heat exchanger or something very easy in our laboratory. And also we develop an experimental apparatus to validate our simulation models. In this apparatus, here this three fluid heat exchanger is here, and air is coming this duct. This duct can be visualized, and the solution is coming from top and from to bottom, and cooling water is coming from here. So totally we can get and heat transfer performance, heat transfer coefficient, mass transfer coefficient. So many detailed performance can be gotten from this apparatus. This is the experimental result. Horizontal axis experiment, vertical axis calculations, humidity, temperature, pressure drop, simulation experimental result agree with each other very well. You can see from this figure. So finally, we try to optimize these heat exchangers. As I've said, heat sometimes are a little bit bigger. So we try to minimize the size of the heat exchanger using AI technologies, genetic algorithms. Maybe you know genetic algorithms we use genetic ways of the human beings. But already this kind of logic is already well developed. We can apply these technologies to the optimization of the heat exchangers. So finally, this is using the optimization, mathematical optimization way using genetic algorithms. Simulation result shows we can reduce 56% of size down of heat exchangers. Of course, these two heat exchangers can get the same performance, dehumidification performance, cooling performance, but we can use more than half of the heat exchange, compactness of heat exchangers can be realized from these mathematical ways. And finally, we can actually develop the actual system just like this. This is a dehumidification systems, and this is a heat pump systems. And these combined system hybrid dehumidification systems. We try to apply this system in the subway systems. Maybe some of you know where that in Japan, so many subway systems are there. And in the commuter time, so many people coming and humidity suddenly increases. That's why this system is very good. And when we apply these systems into subway systems, 60% carbon dioxide reduction can be realized. Normally, you know, most of the air conditioning systems, once is about 1% or something like that in a year. But in this system, 60% carbon dioxide reductions can be realized. Very, very good performance we can get. Okay, this is kind of conclusions. We can develop this kind of completely new liquid materials and liquid three fluid heat exchangers, and mathematical predictions can be realized. And very, very compact heat exchanger can be developed, and this heat exchangers can be applied to the actual system, and very good result we can get. And finally, I talk about future air conditioning systems we are just now focusing on. Of course, you know, COVID-19, this becomes a very big problems in the worldwide level. So we are just trying to develop hybrid ventilation and air conditioning systems. Maybe we can introduce all conditioning systems save human beings. We are just now facing the COVID problems, but in this case, air conditioning system is very important. And also, we can use the heat pump technologies. Normally, we use the combustion technologies, but we can use when we use heat pump technologies, we can contribute a lot to realize carbon neutral societies. So still, heat pump system is, I always think, important. Okay, thank you very much. This is the end of my presentations. This is completely first time to communicate with you, so
Okay.
I want to keep in contact with you forever. Thank you very much.
Okay, thank you very much as well, Professor Saito. I think it's a great, very, very great. And your research is actually, I would say, is the most we are waiting for, because it is very much connected to the, let's say, a Glasgow conference that is about the environmental and energy. And then you try to, I think, reducing CO2, GHG gas, by reducing the use of energy for the same or better output. That is very great, I think. So I think everybody here are interested to maybe to get information more. So would you please have time to maybe some question for from the audience here, Professor Saito?
Yep.
Yeah, okay. So we have, let's say, 9 minutes or 7 minutes to have a question. So please, from audience who has a question, short and direct question to about this one for, to Professor Saito. Please, the audience. Say your name and from your maybe academic, whatever. Yeah. Yes, audience. Okay, if no, there is no one, maybe ask the question or from myself. I think you said that you can reduce almost, if I'm right, it's about 60% something CO2 for this from this using this very accurate let's say equipment.
Yeah.
It is meaning that the energy for it is for the same result, so it is reduced very much. How can you reducing it that much, please, Professor Saito?
Okay. The mechanisms why we can use this kind of deductions, it's okay?
Yeah.
Yes. As just a moment. Yes. As I've said, in the conventional dehumidification way, we have to cool down the air too much, because normally this temperature is about 0 degrees Celsius in the air conditioning systems of the refrigerant, 0 degrees Celsius. But when we apply dehumidification technologies, cool down temperature is about 15 degrees Celsius. So there is big difference of cooling temperatures. That's why cycles of the temperature, lower temperature side, air conditioning consists of lower temperature side or higher temperature side. And if the temperature difference is smaller, the performance is getting better. So that's why we apply these systems. The temperature difference decreases. That's why we can get this kind of higher performance. Yes.
Yeah. Okay. That's great. Okay. Thank you very much. Yeah. Is there any other question, please? Okay, maybe another one, Professor Saito. Yeah, you are facing with two problems. The first problem on the material. The second problem on the liquid. So for the next, which one you are actually put, let's say, a better solution? on the liquid or on the material? Thank you very much, Professor Saito.
Okay, just a moment. Okay, next problems we are just now trying to resolve is still the very big point is still cost. Of course, just now we can apply aluminum conventional system use titanium, so that way we can reduce almost half of the cost we can already realize. But still, this system is a little bit higher, 2 times or something, compared to the conventional systems. So that's why we just now trying to change the shape of this new developed heat exchangers. Because still, heat and mass transfer area is still very small. That's why just now we applied to some metal forms. Do you imagine metal form is very sorry, I can explain well. If I have pictures, I can show you. But the outside fin shape is completely different from this one. So many big heat transfer area we can get if we apply kind of metal forms. So many metals and so many holes, just like this. Can you imagine? So we are just not trying to such a kind of new heat and mass transfer. Very sorry. I'm looking for the pictures, but just now I can. Okay. Anyway, the important point is still we have to reduce the cost. That means we have to make the system more and more compact. That is just now we currently face. So we are just not trying to do so to reduce the size, cost. Okay, that is the next our stage. Of course, the ionic liquid very good for corrosions. No corrosions occurs. It's very good performance. We can already get the actual data. Yes, that is the current situations. It's okay.
Yeah, something problem in the connection.
Okay. Okay, Prof. Samsul, I have one question, excuse me.
Yep.
Yeah, please, Dr. Kasani. Yeah.
Okay. Thank you, Prof. Samsul, for the time. Good morning, Professor Saito.
Yes, thank you.
Ohayo gozaimasu, Saito Sensei.
Ohayo gozaimasu.
Kasani to moshimasu.
よろしくお願いします。ご招待ありがとうございます。
いや、ありがとう。どうも。九州大学勉強しました。
そうですか。よろしくお願いします。
No, it's better I use English. Okay, so everybody understand. Okay, Saito Sensei, from your presentation, I found that one of your interests is heat pump, right?
Yes, correct. Yeah.
Yes, I have visited Akita Daikaku maybe about a couple of years ago, and I found that they also have research on something like heat pump, and the application is on the geothermal. And fortunately, my interest is geothermal. So do you have any interest also, applying the heat pump in geothermal? So because in our country, the utilization of medium geothermal source has not been developed yet. So maybe in the future. So up to now, the geothermal is utilized for electricity generation. But of course, for some places, really, if we can apply heat pump in some areas of Indonesia, is really important or beneficial. So, is there opportunity? You are interested in the applying heat pump in geothermal. Thank you.
Yes, thank you very much. I completely agree with you. Yes, geothermal, we have to use more and more. Of course, in Japan also, we try to use a lot of geothermal energies. And so many big projects Japanese government is just not doing. For example, NEDO project. So that's why.
I think,
And also, this kind of dehumidification system is very good because this system can be driven by very, very low temperatures, 60 degrees Celsius or something. So I believe geothermal we can use for this kind of systems. Okay.
I'm sorry, Saito Sensei. I think we have a problem with the connection, but anyway, we got your message, and maybe we can discuss further.
Okay. If COVID is stabilized, I'd like to visit you and talk a lot.
Okay, thank you very much, Professor Saito. Again, that is a great to hear from you, your research. Okay, so the time to limit to see you. And then again, for this occasion, I think we give great applause to Professor Saito, please.
Okay, thank you very much.
Thank you very much.
See you soon.
Yeah, okay, see you sometimes. Okay.
Okay. Okay, thank you.
Domo arigato.
Arigatou gozaimasu. Goodbye.
Yeah. Arigatou gozaimasu. Iya. Okay. That's great. Okay, so I think this is the time for the next person in the keynote presentation. I think we are very much waiting for this occasion is Pak Krisnawan Aditya from EBTKE. Yeah, that's great. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi Pak Krisnawan Aditya.
Waalaikumsalam warahmatullahi wabarakatuh. Selamat pagi, Prof. Samsul.
Ya, terima kasih. That's great. How about the weather in Jakarta?
Actually, still mendung ya, Pak. Still,
okay.
Like raining lah. Solar ini sekarang ini.
That's great. Yeah. But anyway, we can talk. We sure that Krisnawan Aditya is someone we are waiting for, because from EBTKE, that is actually in Indonesia, that is something, let's say, kebijakan untuk energi baru terbarukan. That is great, very strategic position again, because we already, let's say, Pak Jokowi already pointed ya, ditunjuk sebagai apa namanya menggantikannya dari Italia tentang
Presidensi
environment.
G20. Yeah.
Exactly, that's great kaitannya dengan ini. Jadi dengan of course that's PTKI pasti mempunyai peran yang sangat penting dalam that's let's say energy and climate change as well as untuk kemajuan kita bersama dunia. Gitu. Nah, please, saya kira kita menunggu sekali apa yang dapat disampaikan oleh Pak Krisnawan Aditya di dalam the Thermofluid conference ini. That's the time is for you, Pak Krisnawan.
Yes, terima kasih, Prof. Samsul. Allow me to share my screen.
Sebelumnya kalau boleh saya, but before, I think the better for us, for me, to introduce about your background. This is actually Pak Krisnawan Aditya as background and Master of Engineering in Major Electricity. Yeah, and then works experience at quite a lot. For example, he started from senior researcher in Asia Pacific Energy Research Center, and then come up at the moment as a director of various of new and renewable energy. This is the largest position at the moment, and then of course the publication quite a lot, and then for example in the APEC oil, and then boosting renewable power generation in Indonesia electricity sector, a policy action by the government. Yes, that is very important because as we know that electricity in Indonesia still about 70%, I would say, or maybe I'm wrong, 70% come from coal. That is not quite good for the environment. So what is the next policy? I think we are waiting for a listen from you, Pak Krisnawan Aditya. Please, the time is you.
Thank you, Prof. Samsul. Allow me to share my screen first. Okay, so have you seen my screen, my presentation on the screen? So first, terima kasih, Prof. Samsul. So I would like to thanks for the committee for inviting our Director General. Actually, our Director General supposed to be deliver this presentation. However, at the same time, there is a meeting with the minister. So he asked me to on behalf of him to present related to the renewable energy development in Indonesia. So how is the mid and low term planning and strategy to be developed? So allow me to present. So I would like to emphasize that the energy source and conversion. So we already know, and I don't need to touch more detail about this. But the one thing that a message that I would like to share to the audience in this event is actually the energy is very essential. It is because it most advanced in society and the continuous improvement of the quality of life. And we also have very several experiences in energy crisis. For example, like oil crisis in mid 17th, and this is actually make a catastrophic to the economies of all the countries in the world. And then they are trying to quest the new source of energy to be developed. And in that time, if I'm not mistaken, nuclear is one part of the energy technology to be developed, geothermal, and some part is also coal-fired power plant in order to fulfill the electricity, the energy needs of the people. So, and then suddenly also recently all the global world economies trying to also using the most environmentally friendly of the energy in order to mitigate the climate change and also to keep maintaining the increasing the temperature less than 0.5 degrees. This is actually also mandated, and then there is some commitment from leaders from other countries during the COP26 in Glasgow, just recently happened. So I would like to give the information. How is the Indonesian in order to combating with the climate change and also targeting to reducing the emission in the near future? So actually, if you look at our president directive, we already actually having some commitment during the COP21, which is held in Paris in December 2015. We are committed to reducing greenhouse gas emission for 29% if our self-effort, and 41% if there is international assistance by 2030. And actually, just for information, on top of this target, the target for reducing emission from energy sector is 314 million ton CO2 emission if the target is 29%, and if the target is 41%, then the energy sector should reducing the emission to 446 million ton CO2 million ton. And then also during the Leader Summit, what was held April 2021, the presidents also already mentioning that we are trying to opening up the energy transition investment through the development of biofuel, lithium battery industry, and electric vehicles. And more or less, in during the state parliament meetings, the presidents also already emphasized that we are now going to transforming toward new renewable energy, as well as accelerating green technology-based economy will be crucial change in our energy. And then we are now also going to net zero emission, and we already identification the basic principle toward net zero emission. First is we are trying to increasing the utilization of new renewable energies. And then the second one, we also now trying to reducing the fossil energy through the strategy. One is implementing carbon tax and trading. And the second is we are trying also implementing that steam power plant need to be using a mix with the biomass into the co-firing with the new renewable energy, and also has a plan to making early retirement of a steam power plant. And in the transportation sector, we are also trying to accelerate the implementation, the electric vehicle utilization. So this is the one of our effort in the transportation sector. While in the household and the industry, we are trying to increase the use of the electric appliances in household and electric equipment in industrial sector. And we also acknowledge if there is some possibility, if we still possible to develop kind of the fossil fuel, then they need to use the utilization of carbon capture and storage. So this is actually, I would like to give the information related to the current energy condition. You can see in the slide, actually our consumption, oil consumption is higher. As a moderator said, we still rely on the fossil energies. Yes, it's true. For example, like oil, we production continue to decline while the consumption is relatively increasing. So it is necessary to utilize the alternative energy. And actually, we already having a national energy policy, which is emphasized that the utilization to the primary energy mix should be at least 23% by 2025. However, if you look at the release in 2020, most likely still dominated by the fossil fuel like coal, oil, and natural gas, while the percentage of the share of new renewable energy was only 11.2%. So we need to make it a double in order to catch up our target 23% by 2025. So remaining the time is less than 5 years. So we need to prepare some priority of the development of renewable energy in the coming years. And if you look at, actually, there are still big room for deploying and development of a renewable energy. You can see here, Indonesia is a blessing country. You can see we have so many kind of type of renewable energy, from solar, hydro, bioenergy, wind, geothermal, ocean, and including also nuclear. But if you look at the utilization rate, it's less than 2% actually. So this is also there is a chance for us, for Indonesia, to more utilize of renewable energy in the coming years. So actually, related to the development of renewable energy, the government already issued the RUPTLs. This is actually PLN, electricity supply and demand plan. This planning is a 10 years planning, and this is actually very, very drastically change of the RUPTLs of the PLN. Why? Because if the previous RUPTL is most likely will develop fossil as a big portion, but in this new RUPTL, the portion of renewable energy to be developed is more higher than the fossil one. For example, the total additional capacities to be developed until 2030 is 40.6 gigawatt of power generations, and around 20.9 gigawatt is come from renewable energy power generation. So you can see here there are a lot of type of renewable energy to be developed is come from the hydro power plant and pump storage with the capacity 10.4 gigawatt, and followed by the solar with the additional capacity to be developed is 4.7 gigawatt, and followed by geothermal with the capacity 3.4 gigawatt. And if you look at the composition, this additional power generation to be developed, most likely it will be offered to the private sector. You can see here from total 40.6 gigawatt, around 64.8% will be through the private sector. And in terms of the new and renewable energy, the participation from factors of private sector is also dominated by 56.3%. And if you look at, actually, we are trying to also be equal in developing renewable energy throughout of the Indonesian areas. You can see here from Sumatra, Kalimantan, Jawa Bantu, Bali, Sulawesi, Maluku, Papua. You can see the numbers of renewable energy power generation to be developed until 2030. You can see most likely in Jawa Madura, the what you call the hydro energy source will be dominated to be developed, and then after that will be comes from the solar, and also dominated by the hydro to be developed, and followed by the geothermal. And in Kalimantan, most likely also hydro to be developed until 2030, and then followed by the solar. So this is actually, we are trying to expedite all the potential renewable energy in those regional into a realization of supplying of the electricity. So actually, there is also target to be already putting in the RPTL 2021 until 2030, which is the share of new renewable energy in the power energy mix will be also 23% in 2025. So in order to meet this target, there are also some strategy already putting in the RPTL, such as we are trying to completion of our fast track power program 2 and 35 gigawatt program that will be completed by 2026, 2027. with using the very high efficient technology, which is most likely using the ultra supercritical technologies. And the second, we are also trying to implementation biomass co-firing into the coal-fired power plant of the PLN, with the average portion of the mix of this biomass is 10% in Jawa Bali and 20% in outside Jawa Bali. And we also trying to the contribution of this biomass co-firing can be around 3 to 6%. We also already trying to implement the diesel, converting diesel power plant into new renewable power generation, with the total numbers capacity diesel to be replaced by new renewable energy power generation is around 5,088 megawatt, with some like solar, wind, and so on. And we are also trying to construction additional capacity of renewable energy in terms of the solar and wind, with the capacity 4.7 gigawatt for solar and 0.6 gigawatt for wind. And we need to also replace 1.1 gigawatt new coal-fired power plant after 2025 will be replaced with renewable baseload power plants such as solar, PV with the battery energy storage system, wind with the BESS, hydro PV power plant, biomass, and geothermal. And we also already having some plan to making retirement of 1.1 gigawatt of supercritical coal-fired power plant. This is actually the planning until 2030, or we can say the midterm planning and strategies. Now, I'll inform you related to plan of the Ministries of Energy and Mineral Resources, in particular energy sector toward net zero emission. So actually, we already putting some roadmap in order to going toward net zero emission. This slide is also already presented by the minister during the COP26 in Glasgow, UK. You can see here in the period time of 2021-2025, actually we are expected all the necessary regulation in order to accelerate development of renewable energy should be already completed. For example, like presidential regulation on new renewable energy, and then coal retirement, and also the program steam power plant co-firing, and then diesel to gas and new and renewable conversions will be also completed in the end of this year. And by 2020, we expected also the law of new renewable energy can be also stipulated, and we expected the electric stove can be achieved 2 million households per annum, and the interconnection smart grid and smart meter already implemented. And we expected actually the share new renewable energy can be 23% dominated most for plant. In the second period, in 2026-2030, we expected gradually reduction the imported of LPG, and the new renewable energy in power generation share accounted to 42%, still dominated by solar PV. And in this case, we expected also emission reduction can be achieved as our target into our NDC, which is 314 million ton CO2 emission. And then the third period, 2031-2005, we are now trying to making the retirement, our first state retirement of subcritical of coal-fired power plant. So we expected no more diesel power plant and start to use also hydrogen for electricity, and also trying to increase the battery usage. And we expected by 2035, the share of renewable energy into power generation can be increased to 57%. And in the period 2000, we are now trying to also making the second stage to retirement of subcritical of fossil coal-fired power plant. And we expected the new renewable energy share can be 66%. And in this in 2040, we try to use cells of conventional motorcycles. And then also we expected LED lamps can be 70% to be used. And in the period 2041 and 2050, we expect large-scale ocean current power plant will be operation, and our first nuclear power plant is also can be entering the electricity system. And then 2050, we expected the share of new renewable energy can be 19.3%, still dominated by solar, hydro, and bioenergy. And we expected also reduced sales of conventional cars into the electric vehicles. And the last period, 2051 and 2060, we are trying to using massively utilization of hydrogen. And the last gas fire will be retired in 2054. Sorry. Do you still see my presentation? Okay. And then coal fire will be, the last coal fire will be retired in 2057 year. And we expected by 2060, the new renewable. So there is some possibility that our net zero emission can be sooner, assistance from others countries and organizations, especially in terms of technology and also funding. And this is actually the picture of the electricity supply until from 2021 until 2060. You can see here the energy, the technology of energy source to be developed. For example, coal and gas. There is a policy from the government that there is no additional coal-fired power plant unless it is already contracted or under constructions. And new renewable energy, actually, additional power plant after 2030, we only come from new renewable energy. So start 35 will be netted by variable renewable energy such as solar and wind. You can see the yellow bar here showing that the numbers of solar will be developed. And of we are that the solar and wind is a variable renewable energy, and there is intermittency issues. And in this case, we are also trying to develop storage in order to address the issue of the intermittency of the VRE. For example, like pumps develop battery will be massively deployed in 2021. And hydrogen we also utilize gradually starting from 2031, and then will be massively to be deployed in 2051. Of course, geothermal hydro is will be utilized as a maximum of this potential. And in order to fill the gap, since the coal fire and gas fire will be retired, the nuclear power plant will be also expected to enter to the system by 2049. And this is actually the planning of the coal phase out plan. So you can see here capacity, the increased capacity up to 2026 is come from ongoing project. You can see from the graph. And then passing out coal-fired power plant produce a major contribution in reducing emission in the power generation sector. And then there is no additional capacity to be developed except from it is already contracted or it is already under a stage of the construction. However, we need the legal basis to implement the early retirement. And then we need also support from others country in implement this kind of coal phase out plan. So this is actually there is some support from the international in order to accelerate the renewable energy, while in the other side we also can making early retirement of coal-fired plant. So the scheme called as a Energy Transition Mechanism, ATM. This is actually supported by the ADB. So the concept of this early retirement and boosting the development of renewable energy is the government will try to take over the asset of the previous owner of coal-fired power plant. So there is some funding investment to be given to this previous owners of the coal. And then after that, the government will appoint some entities to operate this coal-fired power plant for some period of time, but less than the expected. So it will be retirement earlier than that expected in the contracts. And then after that, some money is also trying to use to develop a new renewable energy. Of course, the most important thing to implement this scheme is the funding source. So we are now expecting getting the funding from the multilateral banks and domestic and international private sector institution investor, also the long-term investor with low fees and low interest. So I would like to how is in demand side, the long-term strategy in the demand side. Before I already talked about in the supply side most likely. So we are also already prepared the roadmap for the long-term strategy in demand side. For example, in the residential, we are trying to stop importing LPG before 2030, and the LPG production is from new refineries, and electric stove will be introduced to be implemented, and then city gas will be still to be developed, and we are also trying to increase the energy efficiency level for equipment. So it is also good news that Professor from Japan already mentioning related to the heat pump. This is also one part to be considered later on of this implementation of this technology in this residential or air-cooled conditioning. And in the industry sector, we are trying to increase electricity share from 30% in 2020 to 33% by 2060. So we are losing coal share from 35% in 2020 to 12% by 2060. And of course, increasing gas, because this is still being used if there is no any kind source to be replaced. So gas still to be considered to be developed. And of course, the other one is trying to increase the sea level of electricity and thermal. The transportation, we are trying to stop import oil fuel. Biodiesel utilization is maintaining for 30%, even though now we are trying to increasing to 40%. And then the target for electric two-wheelers is 13 million by 2030 and 100% sales by 2040. And electric two-wheeler for 2 million by 2030. This is actually not two-wheeler, but four-wheelers for 2 million and 100% sales by 2050. Electric bus for 6 million by 2030 and 80% sales by 2060. And then we expected also electric vehicle efficiency level, particularly wheelers. In the comment to making energy efficiency program include management optimization, and then EE for significant energy users, EE in the private sector, and so electricity efficient in order to increase with the projected energy intensity NGO, academia, and private sector in making Indonesia more greener in the coming years, order going towards net zero emissions. So its parties into the pentahelix, in the development of renewable energy, into reducing the greenhouse gas emissions cannot be solved or cannot be implemented only by the government. There is some role from NGO, academia, like what M did today to find others new technology related to the source which can be emit less emission. So we are very happy to all the parties from academia, media, NGO, private sector in making Indonesian can toward. That's all my presentation. For your attention and turning back to the moderator.
Okay, thank you very much, Krishna and Aditya. That is, we are very